Good morning and welcome to the third part of data visualization using PyPlot. In the previous part we have studied, that is in part 1 and part 2, we discussed matplotlib library. We discussed the line plot, which we can do using plt.plot function. We also discussed about scatter plots, which can be done using plt.scatter function, and we discussed about bar graph, which can be done using plt.bar function. In this part we'll be discussing histograms and frequency polygon. So what are histograms? Histograms were introduced by Carl Pearson, the same person who had introduced correlation coefficient. A histogram is a graphical display of frequencies represented as bars. It is very much similar to the bar graph. We will see the difference between a bar graph and a histogram. It shows what portion of the data set falls into each category, specified as intervals called bins. And a histogram can be made using the plt.hist function. Difference between bar chart and histogram. A bar chart represents categorical data, which means, say for example, we had created a bar graph showing marks of 5 students. So on x-axis we will have names of the 5 students, and on y-axis we will have marks obtained by them. Whereas in histogram we can have categories. Say on x-axis we can have categories like percentage of marks between 40 to 50, and on y-axis we can have number of students who achieved marks between 40 to 50. Histograms are used to describe distributions. This is how a bar graph and a histogram will look. A bar graph has categorical data. Say in this example we have number of students present in January were these many, in February these many were present, in March so many, and April and May. So bars represents categorical data. On this we have categories, and here we have numbers for those categories. And bar graph, there are gaps between the bars. Whereas histogram, it has frequencies. So here is the interval, and here we can see the number which falls into each interval. So the basic difference between these two is this has categorical data, this has frequencies. Bar graph has gaps between the bars. Histogram, there are no gaps between the bars. Histogram will be clear more once we see one of the examples of how to create a histogram. So let's see an example. Make a frequency table showing the shoe size of students in a class. Say this is the different shoe size of students in a class. Now we have to, first step for creating histogram is we have to arrange the data in ascending order. This data already appears to be in ascending order, so we're not doing that step. The second step is we have to create 2 rows. So this will show the sizes and this will show the frequency. Now we have to divide these data into different categories. How can we decide categories? So our data, the minimum number we have is 4, the maximum we have is 10. So we will divide the data in, say decide how many categories you want. You want 3 categories, you want 4 categories or 5 categories. We can have 4 categories. The first is size between 4 to 6. The second is between 6 to 8. Third is between 8 to 10. and fourth is between 10 to 12. Now the next step is we have to count how many data falls into these categories. So our first category is 4 to 6. We have to count how many data sets we have between, which is between this category 4 to 6. So we have this, we have 4.5, we have 5, we have 5. Now the question is whether to include this 6 in this or in this, because this is from 4 to 6 and this is from 6 to 8. So 6 is included in both the categories. So where do we count this 6? Do we count in this category or do we count it in this category? The answer is we count it in this category and not this. So this is 4 to 6, which means all the numbers which are greater than or equal to 4 and less than 6. This category means numbers which are greater than or equal to 6 and less than 8. This category means numbers greater than equal to 8, less than 10, and this means numbers greater than equal to 10 and less than 12. So in this category we have 4 values. So we write 4 here. Now the next category is 6 to 8. So in 6 to 8 we have 6 and 6.5, 7, 7, 7. We have 5 numbers falling in this category. So we write 5 here. The next category is 8 to 10. So numbers which are greater than equal to 8 and less than 10. So we have 8 and 9.5. We have 2 values which is in this category. So we write 2 here. And finally we have 1 value which is in this category. So we write 1 here. So this is our frequency table. Now based on this frequency table we can draw a histogram. This is how the histogram of this data value will look. We will learn how to create a histogram in the next example. This example was just to learn the frequency table. So if how to create a frequency table is clear, we can move to the next example in which we will be learning how to create a histogram. And I hope how to create a frequency table is clear. The first step is we arrange the data in ascending order. Second step is we find the minimum and the maximum value. Third step is we decide how many categories we want for that data set. Next step is we calculate how many values fall in each category and we create the frequency table. Once the frequency table is created, we can create a histogram. So in the next example, we will learn how to create a histogram. So we already have a frequency table here where in this row we have prices, a price range of pens, and we have in this how many pens are sold in each price range. So our first group is from 10 to 20, that is pens costing more than 10 and less than 20. So the exact cost will be pens which cost between 10 to 19, and we have 15 pens sold in this category. The next category is 20 to 30, means pens costing between 20 to 29. We have 20 pens here and so on, which means the upper limit of one interval is the lower limit of another interval, making it continuous. See here, the upper limit is 20, which is the upper limit of this interval, but 20 is the lower limit of this interval. 30 is the upper limit of this interval, 30 is the lower limit of this interval. 40 is the upper for this and it is the lower for this. 50 is the upper for this and it is the lower for this. So the upper limit of one interval will be the lower limit of another interval. So once our frequency table is made, we can draw a histogram. The first step to draw a histogram is to draw the x and y axis. Let's draw x axis and y axis. This is the x and this is the y axis. The second step is label the axis. So we label x, y. This is the intersection point, so it's 0. On this axis we will show the prices of pen, and on this axis we will show the number of pens sold. The next step is make equivalent intervals on each axis. So we make equivalent intervals on x-axis and equivalent intervals on y-axis. Next step is choose a suitable scale for y and x-axis. Scale means the numbers which we will be writing over here. Now on x-axis is the price range, which is 10, 20, 30, 40, 50 and 60. 10, 20, 30, 40, 50, 60 and 70. Okay, we don't need to write 10 to 20, 20 to 30. We just write 10, 20, 30, 40, 50, 60. And on y-axis, our range is this. The lowest here is 5 and the highest is 30. So we have to decide numbers where both these numbers will be covered. So I have written 5 to 35. Okay, here is the interval of 5 and here I have interval of 10. So once the scale is ready, the next step is to draw bars for each class interval. So our first interval is between 10 to 20. We have sold 15 pens. So between 10 to 20, 15 pens are sold. So first bar will come here between 10 to 20 and 15 pens. The next bar is between 20 to 30, 20 pens. So between 20 to 30, 20 pens. So next bar should come somewhere here. Between 20 to 30, 20 pens. The next bar is 30 to 40, 30 pens. So in this interval, we have a bar from here. 30 to 40, 30 pens. 40 to 50, 25. 40 to 50, we have 25 pens. And finally 50 to 60, we have only 5 pens. So this is how a histogram will look for this data set. This is the histogram for this data set. Your bars are continuous, there is no gap between the bars. So that is the basic difference between a bar chart and a histogram. And I hope how to create a histogram is clear with this example. Intervals are also called bins. So this, what categories we have created here, it is also called bins. Now let's see one practical using the histogram. I've already written some code here. Import matplotlib.pyplot as PLT. All our functions are in the PyPlot library, so we have to import it. I've also imported numpy as NP because the first graph which I will be creating is a graph of 1000 random numbers. So in Y I am having 1000 random numbers, and then simply by writing plt.hist and passing Y as a parameter, I am creating a histogram of 1000 numbers. This is the title of the graph. Value is the label for x-axis and frequency is the label for y-axis. This is how the histogram will look. By default, the 1000 numbers are divided into 10 bins. So by default, Python creates 10 bins for each data set. So this is bin 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So by default Python creates 10 bins. We can increase or decrease the number of bins by adding the bins parameter here. Bins equals to 25. If I write bins equals to 25, now these 1000 numbers will be divided into 25 intervals decided by PyPlot on its own. If I write bins equals to 5, these 5,000 random numbers will now be divided into only 5 categories, and the histogram we get will look like this: 1, 2, 3, 4 and a very tiny fifth here. So this is how histogram will look. Now here it is not very clear because all the bars are joined. We can add a edge color here, EDGE, edge color equals to, and you can give any color variable. I am writing R, which stands for red. You can even write red here. Now we have a edge color for, now the edges are defined, so we can see that this bar is different from this is different from this, and so on. Similar to edge color, we also have face color. By default it is blue. We can change it to any color we want. So write face color equals to, and then give a color name. G is for green. You can also write green, GREEN, green. So we have green bars and the edge color is red, so we have red edges. Okay, lastly, there is a function called savefig, which normally if you want to save this figure, you click on this button and you give a name here. Okay, this can be done within the program by using plt.savefig function. You write the name of the figure, whichever name you want to give, .png. So if you do this, the figure will, your chart will be saved automatically. This chart is created and it is saved with the name histogram.png. If you want to see it, it will be saved in the local directory. From here you select all files, and somewhere here histogram.png. So that is the savefig function. So we created 1000 random numbers. We plotted it using the hist function. Bins is the categories, how many bins you want to create. Face color is for the color of the bars. Edge color is for the color of the edges. plt.title will give the title to your graph, this. plt.xlabel is the label of x-axis. plt.ylabel is the label of y-axis. plt.savefig will save this figure on your drive with the name you pass as a parameter, and plt.show will show your figure. Now let's create the histogram with the same values which we created histogram manually here. Now let's try to create a histogram in Python using these values. I've already written the program here. Bins, if you just write bins equals to 5, it will create 5 bins on its own. Here I have given the range for bins. Weight is the values, these values, 15, 20, 30, 25 and 5. These are the values we pass as the weight parameter, and this is the scale for y-axis, 10, 20, 30, 40, 50. You have to make sure that these numbers, that is what you pass here, and the numbers are same. There are same numbers are same doesn't mean that it should be 15, 20, 30, 25, 5, 15, 20, 30, same numbers here. It should, the value numbers should be the same. So there's 1, 2, 3, 4, 5 numbers here, 1, 2, 3, 4, 5 numbers here. So the numbers should be same. I cannot have 6 numbers here and 5 numbers here, then I will have an error. Or I cannot have 6 here and 5 here, again I will have an error. So the total number of values for this and the number of values for this argument should be same. We have almost same histogram. The only difference is here the edge can be seen, here the edge is not seen. You know how you can get the edge values? By writing edge color here. Edge color equals to now we can see clearly that between 10 to 20 we have 15, between 20 to 30 we have 20, 30 to 40 we have 30, 40 to 50 we have 25, and finally we have 5. So this is the histogram. Now there's one more parameter, which is orientation. By default we get a vertical orientation. If you want a horizontal orientation, you have to write orientation equals to horizontal. You will have the same histogram but in a horizontal way. All the x and y axis will change on its own. So the entire orientation of histogram will change from vertical to horizontal. By default is vertical, so if you want a vertical histogram you don't need to write this. If you want a horizontal histogram you have to write orientation equals to horizontal. The next parameter we will learn is hist type. By writing hist type equals to step, we will have a histogram which is not filled with color. We will only have the outlines. So it looks like a step. This we can get with hist type equals to step parameter. So we learned to create a histogram using random values. We changed the number of bins. We defined the edge color. We defined the face color, and we also learned how to save the figure or save the histogram. The next topic is frequency polygons. Frequency polygons are used to understand the shape of distribution. where is the peak of the distribution, which is the lowest point on the distribution, which is the highest point of distribution, we can clearly see using a frequency polygon. It is used for displaying cumulative frequency distribution. What is cumulative frequency? I will show in a while. But first let us see what is a frequency polygon. This is the histogram we created in previous example. Now for creating a frequency polygon on this histogram, we just have to place a dot in the middle of every bar. So we place a dot here, we place a dot here. On each middle of each bar we place a dot. And the next step to create a frequency polygon is we join all these dots with a line. So now this shape is called the frequency polygon for this histogram. In Python there is no function to create a frequency polygon, but you can be asked to draw a frequency polygon manually. So this is how. First you have to create the histogram, then you have to place a dot in the middle of each bar, and then you join all the bars. A polygon is a closed shape, so you need to have a starting point and a end point. So this is how you can create a frequency polygon. Cumulative frequency. Now what is a cumulative frequency of this data set? It is the same data set which we learned in the previous example. For better understanding, I have just from a horizontal table I have made a vertical table of the same data set. So on this column we have a price range of pens. In this column we have its frequency, which is given here: 15, 20, 30, 25, 5, 50. Okay, so this 15, so we can say that in the price range of 10 to 20 we sold 15 pens. In the price range of 20 to 30 we sold 20 pens. Price range of 30 to 40 we sold 30 pens. Price range of 40 to 50 we sold 25, and so on. The cumulative frequency is, we will have price range of 10 to 20 we have sold 15 pens, so we will write 15 here. 35, how did this 35 come? Now this number is the price range between 10 to 30. So how many pens have we sold between the price range of 10 to 30, which is 15 plus 20, so 35. This is the price range between 10 to 40. So how many pens are sold between 10 to 40? So it's 15 plus 20 plus 30, that is 65. How many pens have been sold from the price range of 10 to 50? So it's addition of these, which is 90, and finally we have 95, which is the price range from 10 to 60. So we have 95 pens. The same can be done in Python. Just by writing cumulative equals to true. This will give us a cumulative histogram. The values we calculated here were 15, 35, 65, 90 and 95. So 15, then 35, 65, 90 and 95. The cumulative histogram will always be in ascending order. So I hope what is cumulative frequency is clear. Now let's try to create a histogram on your own. I will just give you some hints and you have to complete the remaining. I have given you grades of 15 students in a class. So these are the grades of 15 students in a class. And you have to build a histogram from this data. So your first steps should be arrange it in order from lowest to highest, and then find the lowest and the highest value. The lowest value here is 48. The highest value here is 97. So now you have to decide how many bins, means how many categories you will divide the data in. Our lowest is 48 and highest is 97. So we should create categories which will include both these numbers. So let's create categories, 6 categories. The first is between 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90 and 90 to 100. You write down the categories as scores, and then you have to count how many what number will come here. Okay, so the first category is 40 to 50. So between 40 to 50, how many students have got grades between 40 to 50? It's 48. So 1, I think only 1. Then you have to find out how many students have got between 50 to 60, 60 to 70, and you write the numbers here, and then based on those numbers you can create a histogram. So that's your assignment number 1. Your assignment number 2 is here. Given the following set of data, weight measurements of 14 values of muffin, these are the values. Based on these values, you have to create a simple histogram, which can be done using the hist function. Then you have to create a horizontal histogram. Remember the orientation parameter. Then you have to create a step type of histogram. Remember the hist type parameter. And finally the cumulative histogram. This you have to write code in Python for these, as well as you have to draw a manual histogram and do all this manually. So I hope what is a histogram, how to create a histogram, what are bins, how to decide the categories, what is cumulative frequency, what is frequency polygon. These points are clear. If you have any doubt, you are most welcome to ask me. I will be happy to answer. In the next part, we will be learning about box plot. But first, complete this assignments, and if you have any doubt in this, please feel free to answer.